Business analysts gather and analyze data to identify areas of a business or process that can be improved. In today's business landscape, it is common for people who analyze what a business does or what it needs to work with data. But they do not necessarily need to be a data analyst to get things done. Hi, I'm Ana Corinhotis. I'm a database analyst who helps business analysts understand how they can use basic data analysis methods in their job. Welcome to the Basic Steps of Data Analysis, a planning guide for business analysts. This video lists and illustrates the 5 basic steps of data analysis that will give entry-level and aspiring business analysts such as yourself a good idea of how to tackle data-related questions through a series of tasks that can later be applied on the job. At the end of this video tutorial, you'll be able to list the 5 steps of data analysis, understand, explain, and appreciate the 80% rule, and start to break down your own data analysis tasks in a project. Business analysts may collect relevant data and compile information that will provide them with an understanding of what is happening with the business. A business analyst working in the tech industry, for example, might document the requirements of a new feature such as a like button on a website application and propose a redesign to their IT team of developers. The analyst may also work to ensure the effectiveness of the redesign by surveying customers. They can use the survey results in order to assess the level of effectiveness and make the appropriate recommendations to the IT team based on that customer feedback. As a business analyst, you most likely will not be called upon to dive too deep into analyzing data. Your focus will not be on predicting any behaviors or foreseeing patterns and trends in the data. This is more under the responsibility of the data analyst or the data scientist. Instead, you as a business analyst will focus primarily on discovering and describing relevant findings, coming up with decisions and solutions that are driven by the data. You will then communicate that information to relevant stakeholders such as management, other business analysts, and customers. Since the goal here is to gain insights of a business or a process, then you as an analyst can apply the concept of data analysis in your work. But what is data analysis anyway? Data analysis is the process a person can use to clean, introspect, change, and model the data. The goals of discovering and deciphering novel information, coming up with solid conclusions, editing, formatting data properly, and validating a particular decision-making process are all accomplished through data analysis. Data analysis can be broken down into 5 steps. The first step of data analysis is identifying the problem or the issue. Sometimes this is not as easy as it sounds. The importance of properly framing your problem should never be downplayed. If you do not properly understand the problem from the get-go, it can lead to incorrect results and many hours of work that eventually lead to an undesired outcome. Initially, you're going to focus on gathering and collecting the data that you believe will help to address the problem. You need to ask questions such as, who are your stakeholders? What are their expectations? What are the performance metrics that you're going to use? Once you've outlined who is involved and what their interests are, then you can look at what data is relevant. A big part of the data collection process actually starts in the identification of the question itself. The second step is the collection of the data. Being clear about your goals should drive your efforts in collecting and using the data. And a lot of this is going to be decided based on your stakeholders' outcomes. When you know what data is relevant and what data would help you to answer your question, then you need to make certain decisions about the data. This includes variables such as categorical versus quantitative data types. How do we use these variables? What do they mean? Also, you need to establish relationships or connections between these variables or the various data sets. Only then can you finally collect and ingest the data before moving on to the next step. Data cleaning can be referred to as the process of fixing incorrect or incomplete data within a dataset. Why is it important? Any clues? Well, if the data is incorrect, then the outcomes are incorrect and unreliable. There is actually no one cleaning process because this is going to vary from dataset to dataset. What I'm going to do is list a few methods of data cleaning that you can choose to follow. You can typically start with removing any irrelevant records or observations, typically known as duplications. For example, if your data set includes customers who did not submit a survey, then you might want to remove completely this set of observations. Or if for some reason you have the same customer with the same question and answer showing up more than once on your survey data, then you might consider removing it due to redundancy issues. You may need to fix some structural errors as well, such as typos, incoherent naming conventions. Any other structural errors that you can think of? You may have data that don't jive with the rest of your observations. These are typically known as outliers. Outliers are one-off observations that don't fit with the rest of your data set. For example, in thousands of records that include the ages of customers, there's a single customer whose age is set to 210 years old. Amazing. But this is probably a clerical error, and amongst thousands of records, it might be all right if you chose to remove it. It may not skew your result sets at all. But in all cases, your choice of whether to keep or include a possible outlier, if you've defined it as such, will be based on a legitimate reason. Next, you may have records that may have missing data. You could have 10 columns of data, and for some observations, you'll be missing values. For example, we have lists of home addresses with countries. What are you going to do about the missing values? Are you going to replace any null value with a not indicated text? Are you going to choose to delete completely those records? Are you going to fill in the country based on a postal code or region? In any case, you will need to justify your decision and also explain it to your stakeholders. You do not want to lose integrity or credibility due to a lack of explanation for your choices or a lack of context around your data decisions. Finally, you need to evaluate everything. Ask yourself if the data makes sense, if your decision to keep or delete stuff is correct. Do the rules you've applied in this phase allow for preparing the data in a later phase? If you feel something is missing or is out of place, then you may want to consider going back to the collection phase before moving on. You may need to pull in more or even different data. The reality is that you may likely have multiple ways you will need to clean your data. You might find that some addresses or cities have lowercase or uppercase mixed up, so you will need to account for that. Let's talk a little about what it means to have a structured data set. A good data structure makes it easy to perform calculations, filter, sort data, create charts and pivot tables, and apply formulas and functions in software applications such as Microsoft Excel. A bad data structure can lead to errors, confusion, and inefficiency. For good spreadsheet data structure, remember, format your data like a database. Make sure all header rows are the same. Check that every row and column contains data. And please avoid merging cells. It is important to know what each record or row that your data has represents. Only when you know what each record means, then can you prepare your data for analysis. Now think of a record as a row in your Excel sheet. A column of data should contain items that can be grouped into a larger relationship. For example, the column year will contain a calendar year. It would or should not contain the name of a term or even one of those categorical values such as male or female. This would be incorrect. The value in that cell should contain items that are to be expected in that domain. It is also important to check the integrity of those values. Can anyone spot the problem here? Another aspect of cleaning and preparing your data has to do with merging, the combining of multiple data sets. Whenever you have multiple sets of data that may not have similar information in them, odds are that you will have to clean them separately. And after you've formatted them, each data file, you may need to merge or combine them. This is also referred to as transforming the data. This is where you need to decide how the data is related. Here is an example. How would you merge these two files? What would you need to consider when merging? What is the common identifier? We have gone over a lot of information about cleaning and transforming your data to prepare it for analysis. Now let's look at what you do with the clean data, how you can further analyze and summarize it, and finally, how you visualize it and communicate it, and then share it with others. The fourth step of data analysis is, funny enough, analyzing of the data. You have the raw data that is formatted and cleaned up. Before you summarize the data and put it in a proper format that's going to be used for populating a chart, one recommendation is that you step back and confirm who your stakeholders are. What are they expecting to receive? This will drive the metrics that you will be creating. By metrics, we refer to things such as key performance indicators. Additionally, think about the measures that you'll be using. By measures, we mean count, sum, min, max, or average. Finally, you need to visualize how your analysis will help to solve the problem or answer the question. Let us look at an example. This is a summary table of survey results. The detailed survey questions and answers submitted by your customers need to be analyzed in order to understand customer experience using your organization's online interface. By compiling some basic statistics, you can see almost immediately that there is significant discontent with one feature, and you may need to explore this functionality of the product a little further. One way is to isolate the answers to the question in particular and look at the customer comments to get a better understanding as to the reason or reasons that they rank this feature so low on the scale. You then can take this data-based evidence and recommend to your programming team to make a change to that feature, something that may suit the needs of the majority of the customers. This next and final step of data analysis focuses on the presentation of the data. It includes visualizing it and communicating it to your various stakeholders, who may be your developers or customers. Questions you need to consider in this step include: what are you attempting to model or show with the data? What are the limitations to the model? Which chart types are most effective? What additional context will you use to address the question? Consider the survey data from the previous example. Your goal may be to show or model the negative experience with the interface and focus on that single feature. You may decide to first reach out to your customers for further input regarding their negative experience with that label, that like button, whatever that feature is. Then, compile that additional information, include it in your analysis before presenting your findings and recommendation to your IT department. You can present all this with one or more data visualizations accompanied by descriptive text in the form of a PowerPoint presentation or a PDF document. Whatever your deliverable is, whatever your recommendation or evaluation is, it will be more effective when supported by data. And visualizations are proven to be highly effective in communicating a message. But let us first give a simple definition. Data visualization is described as the visual representation of data in the form of graphs, maps, infographics, or other tools. It is used to communicate information in a clear and effective way. According to a Salesforce article, visual content is processed much faster and easier than text. This is backed up by science. Researchers at the Pennsylvania School of Medicine calculated that the human retina transmits visual input at 10 million bits per second. That's pretty fast. By embedding data visualizations in your materials, you can take advantage of this and display insights and trends that may be missed in tabular reports alone. There is a caveat to embedding visualizations. They may not accommodate all audiences, such as viewers with a type or a degree of visual impairment. This, of course, is something you need to consider in the first step of data analysis, where you're defining your stakeholders, aka your audience. Business analysts use data to identify trends and problems, and ultimately to make certain decisions. They focus typically on the strategic and conceptual level, working closely with various stakeholders from gathering business requirements to recommending changes in a business process. This video showed you how you can use data analysis as part of your tasks and duties and to support your project objectives, whatever those are. We went through a real-world example around evaluating a feature on an application where the data gathered and analyzed was presented to developers in a way to propose a redesign. You may have noticed that the steps that took the longest time to cover in this video were the first three: identify a business question, collect, clean, and prep the data. There is a reason for this. According to various research studies, 80% of the work in any data project is cleaning and preparing the data. This is often referred to as the 80-20 rule or dilemma. Not exactly the most glamorous part of the job, but certainly the most important. Why is that? Data cleaning enhances the results one gets from their analysis. Having a clean data set means you have ample resources to work with to help create the insights needed in the analysis. It increases productivity and reduces the time taken to get the insights. Finally, data cleaning removes errors from the data set and can be used to solve the incorrect or corrupted data collection. I now invite you to use the steps illustrated in this video to support your own business analysis, no matter how short or long-term your project may be. And remember the wise words of John Wooden, an American basketball coach and player: if you don't have the time to do it right, when will you have the time to do it over? Thank you for watching, and happy analyzing!